The first thing we're going to look at in our study of trigonometry is angles and their measures. All right. Now, when you first study angles in geometry class, I believe they call an angle an undefined term. They just tell you that it has no definition. It is just something that is formed by two rays that share a common endpoint. Okay. Now, once you get into trig, you're going to have a little bit of a different definition of what actually an angle is. All right. So we're going to start this off by just looking at this graph here. All right. What is this the graph of? It's just the graph of a circle that has a center at the origin, right, where that college graduate is standing, and it has a radius of 1 unit. Okay. And that soccer ball there is along the circumference of this unit circle. Right. It's called a unit circle because it has a radius of 1 unit, right? Unit meaning 1. So what can we do here? We can have this soccer ball begin to travel along the circumference of the circle counterclockwise, starting from the point 1, 0. Okay? And once we've done that, what do we end up with? We end up forming what you probably think of as an angle. Okay? And yeah, we found an angle. But now here's the issue. There's two different ways of looking at this angle. Okay? We can look at this angle from the perspective of the soccer ball, right? How far has the soccer ball moved from the point 1, 0? And we can also look at it from the perspective of the college graduate. How far has the college graduate rotated to keep his or her, you can't really tell if it's a male or female, eye on the soccer ball? Okay? So what's going on here really is two different things. One is the college graduate is rotating as the ball is moving, right? So the ball is moving around the circumference of the circle as the college graduate is rotating. And really that's just the two different ways that we can measure angles, right? So we can think of the amount of rotation of the college graduate, right? The college graduate really isn't rotating because it's not animated, but what you can do is you can assume that it is rotating counterclockwise to keep its eye on the ball. So the amount that the college graduate has to rotate to keep his or her eyes on the ball would be degree measure and the distance, right, that the soccer ball has moved around the circle, that would be what we call radian measure. Okay? So those are the two ways of measuring angles, either in degrees or radians. So you can think of degrees as the amount of rotation and radians as the distance traveled around the unit circle. Okay, so now that we've discussed the two different types of degree measures, right? Angle measures, degrees and radians, we got to get some kind of relationship between the two of them. Okay? Now, you probably realize that this is just, most people know this, that one full time around a circle, right? If you make one complete rotation around a circle, oops, got to back up a little bit, right? Can't make it exact. You have traveled 360 degrees, right? So one full rotation around a circle in degree measure would be 360 degrees, right? That's a full rotation. Now, in terms of this soccer ball, what is the soccer ball doing? It's traveling around the outside of the circumference of the circle. So if it's gone one time completely around the circle, how far has it traveled? Well, you may recall the formula for the circumference of a circle, which is circumference is 2 pi times the radius. And in this case, we said at the beginning, right, the radius of the circle is 1 unit. So the circumference is really 2 pi times 1, which is really 2 pi. Okay? So when the ball has traveled completely around the circle once, it's going a distance of 2 pi radians. So right here we have our relationship. 2 pi radians and I apologize for the way this writing looks. This is supposed to be a fancy stylus, but it's not too good. 2 pi radians is 360 degrees. So if I want to make this a little simpler, I guess, I could divide both sides of this by 2. So I would have that pi radians is really 360 divided by 2, which would be 180 degrees. Okay? So this is our, what we would call a conversion factor. If we ever want to convert from degrees to radians or radians to degrees, we use this conversion factor, the fact that pi radians is equal to 180 degrees. We can see in this picture here that the ball has traveled 1/8 of the total distance around the circle, right? This would be 1, 2, 3, 4, 5, 6, 7, 8. So what would this angle right here be equivalent to? Well, it's 1/8 around the circle. And remember, the circle has a circumference of 2 pi. So this angle here would really be 2 pi over 8, which is really pi over 4 radians. So that angle will be pi over 4 radians. And again, here's a simple way to think about it. You know this, right, from geometry, that would be a 90-degree angle. So this is exactly half of that 90-degree angle. So this is actually 45 degrees. So pi over 4 radians is equal to 45 degrees. Now, how would we have gotten that, without thinking about it analytically like this? We can just basically use our formula, which says, all right, if I want to convert pi over 4 radians into degrees, what I'm going to do is I'm going to multiply by my conversion factor, which is the fact that pi radians equals 180 degrees. So I'm going to multiply this by 180 degrees over pi radians. And then what happens here, of course, is that your pi's are going to cancel out, and you're going to have 180 divided by 4. And 180 divided by 4 is really 45 degrees. And then you could also go the opposite way, right? If I wanted to convert 45 degrees into radians, I would write my 45 degrees, but then now instead of multiplying by 180 over pi, I would multiply by the reciprocal of that, which was pi over 180. And again, I'm going to get some cancellation here because 45 over 180 is really 1 over 4. And I'm going to end up with 1 pi, which is just pi over 4 radians. And RAD is used as the abbreviation for radians. Okay, so that's what I did. That process will always work when I'm trying to convert between radians and degrees. Right, when I want to go from radians to degrees, I multiply by 180 over pi. When I want to go from degrees to radians, I multiply by pi over 180. And then I just simplify it, right? Cross cancel, things like that. Okay.